Hi everyone. So this topic's very tough because Jeff stole it all in one slide earlier today, but he did credit Cisco, so that's all right. Thanks, Jeff. I just want to I was just commenting on that purple box that Lincoln showed. I'm pretty sure that's an extreme network switch and nothing to do with Amazon's custom hardware at all, but we'll see. Anyway. So I've been around the SP industry a long time, in Australia and around the region. This talk is about many things. Quick is one of them. But I think, having been through generations of silicon refresh, core network refresh equipment, this is time we can turn off all that QoS stuff. WRED, don't need it anymore, won't do anything. So every time a customer talks to us and says, that thing you used to doesn't work so well on this new silicon, we can just say we don't need it anymore. It's not going to achieve anything. Anyway, just before we go on, lots of the work that was done in Cisco on this topic was done by a colleague of mine, Mark. He was a consulting engineer, worked with many mobile operators, so a lot of this data has come from mobile operators. Sadly, Mark passed away a couple of years ago, but lots of this work was done by him, lots of data was done by him, and then we've kind of taken that work forward across the company to try and find some solutions to customer problems. Okay, so there's really three topics today. So one is about the new internet, both probably topology and protocols that are being used on the internet. Obviously, they've had massive changes to how we build networks. So sometimes working in a vendor, we don't always know everything that our customers are doing with the stuff we sell. But certainly we have seen a big change in how people are building networks. And as I said, I think things like quality of service, things we've been doing for a long time, probably are ripe for a change and a bit of a mix-up. And also, I do have I don't know if anyone from NBN here, but thinking about how things like the national broadband network would evolve going forward, we can't necessarily build it the same way we did when we started 10 years ago, because people like the web scalers are changing how vendors like us build silicon, how Broadcom builds silicon. Lots of the things that we used to do aren't cost economic anymore to meet the increasing scale. So the new internet is the first piece. Then we'll look at some tools we think we have to help managing this new internet. Jeff will throw rocks at me, but I've got friends with PhDs who throw rocks back at him. I'm not armed to do so. And then lastly, some of the use cases that we have for the tools. Okay, so as I said, the first part of this presentation is quite a bit of data. Jeff shared some of it. Cisco, as I said, started this work in mobile operators. We have a mobile core that's deployed quite widely across the world. And there was a piece of technology within that was used to get much of this data. So a lot of this is mobile-centric. I think you'll see with statistics, depending where in the network you are looking and what type of, where you place this analytics in the network, you'll get different things. So mobile, obviously we have mobile devices, lots of apps on our devices. People don't use browser as much as more the apps. And in parts of the world, some parts of the world are fully mobile first and nobody has a computer at all. So it's different experiences where you are in the world. But what you can see here, going back to 2020 even, we would see that on top left here, 90% of the traffic was already encrypted that we were seeing in the mobile networks, and 70% of the volume was to basically 10 locations, or 10 of the elephant sites. And as I mentioned before, that's obviously changed how I know operators have built their networks, because you've got to basically handle how you have this sheer shift of volume into these players. On the right-hand side here, the other piece other than just volume is that DNS. I think, again, Jeff said it was pretty important this morning. So 50% of all the flows through the mobile networks, we did this piece of analysis with, 50% of all the flows were DNS, so we know that's important. And even back to 2020, 20% of the traffic was quick back then. So we'd started to see, obviously it'd been put through standards, I think started around 2013, but we started to see an uptick of quick back in 2020. So as I mentioned, Cisco has many operators we work with on their mobile cores. So this data is largely from mobile operators. You can see on this chart that we started back in 2020 and 20% of traffic was quick. Looking at a few North American operators in 2021, we were up to between 25% and 40%. And then if we accelerate through here, you can see the chart. In 2023, we were at 45%, roughly, depending on the operator. And you can actually see Latin America is one of the kind of economies areas where it's a mobile-first centric environment, right? So everything runs off their phones. So, and everything's pre-contained in the app. So therefore, we've seen a higher uptake and a higher percentage of that sort of traffic in emerging markets. I think this is the one you stole, Jeff. If you want to take another picture, please free to do so. Okay. So look, the traffic volume is one piece. So you can see, again, this is another way of representing it, I think, is that the big 5 networks, so YouTube, Instagram, Facebook, and who else is there, sorry, Netflix, yeah, and Facebook Video was nearly half of all the total traffic volume. So we talked about the big 10, but actually the big 5 is half. You can also see, this is back in 2022, 40% of that traffic is quick. Interestingly, you'll see that YouTube was mostly quick, Insta's all quick. Facebook, though, was lagging behind and still using quite a bit of TCP for their traffic. I don't know the reasons, but I'm told it's pretty easy when Facebook wants to. They can just flick over to quick. Maybe it's something to do with the fallback you mentioned, Jeff, earlier about, I think, the server timeouts or something I didn't fully understand, but maybe. But anyway, Facebook was a bit lagging behind. In terms of total flows, you can see TCP is still dominant, but Quick has a very large number of the flows, which you'd expect, but probably less of the overall total. But this is from, again, a EU operator in 2022. Obviously, many people in this room will not be mobile operators, but we do have a study done with a broadband operator in Europe. This was done using the same tooling that we have, but basically we exported EDRs from their BNGs and imported them into our mobile analytics software. But you can see here, again in 2022, again 40% of all their traffic on the fixed broadband network was quick, and the same kind of phenomena that a few big content hosting sites were the bulk of all of their traffic. A slightly different mixture of that on this network because it's fixed broadband. We expect to see different applications in use. But broadly, this is the same themes that Quick is becoming dominant. So fast forward to this year, we have 3 more studies we have done. So one in Latin America, you can see here, they have the highest adoption of Quick in this operator of any we've done a study with. And again, as I mentioned, I'm told this is largely around this mobile-first economy, where you can see, it's nearly half of all of their traffic. As a counterpoint to this, in the US, this study was done with a fixed wireless access operator. So again, they'll have different device mixes, probably more laptops, more PCs, those kind of things. But you can see, Quick is still on the rise, but not anywhere near dominant yet. But obviously we'll get there. One other thing I wanted to point out, so while I'm here, just came to my mind was, our studies here are all with service providers. We are starting to try and do some studies with enterprise. Obviously, Cisco has a large enterprise networking business and many enterprise customers. We have the same things with Silicon and QoS and all those things we've been doing for a long time in the enterprise space. So we are trying to start accumulating some data on what's happening in the enterprise. So I think the hope is within a year we'll have some of that. But obviously, many end customers would be enterprises, and probably that will have an impact from the service provider point of view about whether you need to do anything or help your enterprise customers. But we're sort of starting to try and get some data on that as well. I am told, Jeff, this is one of your slides. I'm told, this chart here. So thank you. So look, essentially here, I think we've said this, that TCP had some assumptions, the networks had some assumptions that TCP would be dominant. Like I said, in QoS particularly, we would drop traffic randomly when we saw congestion and TCP would back off, and generally life would be okay for those applications and those users, and it was built around the notion of fairness. And Jeff could probably come up on stage and summarize this better than me, but I think what Jeff was trying to show in his study here was that essentially in the bottom case here, when we have TCP, you can see the volume of traffic that's transferred through multiple TCP flows through a network is roughly equivalent because TCP has a notion of fairness. The quick-based applications will grab everything they can. Obviously, they have their own flow control mechanisms built into the application, but they're controlling it purely from the application, and not from a network-centric point of view. So that's not necessarily wrong, it's just that the application is now in charge and not the network. So the summary here is that Quick is becoming dominant and that 80% of the, we have to build our networks towards the 80% rule. So Quick will be dominant, so we need to start building towards that rather than building things the same way we have been. So in terms of protocol stack, I think we had a pretty good summary of what Quick was all about this morning. So what we're trying to show here is we had TCP/IP for a long time with TLS and HTTP. Now we have transitioned towards Quick with TLS 1.3 and HTTP 3. We also have other encryption happening as well. So we have moved towards DNS over HTTP. I don't have volumes of how fast that transition's happened or how much of it's happened. And in doing some reading for this, obviously we have DNS over Quick as well now. So I don't have a traffic profile of which one's dominant, what the growth of DNS over Quick is, but we are seeing everything being more encrypted and more secure. And finally, we used to be able to infer quite a bit of data from the SNI, or the server name indicator piece of information. That is all becoming encrypted with ECH now as well. So we're seeing everything more and more being encrypted. And I think that was an interesting observation that this is for the benefit of the, probably for the web scalers and not for the benefit of end users, but it is what it is, and probably not going to change. So as I said, Cisco's mobility business had a packet inspection-based capability, so did many other people. We used to use that to set policies for users on the network, who could do what applications were prioritized, how we could do zero rating, all of these kind of cool things. But clearly, that is not going to work anymore. The last piece here, we talked about, I guess, the big five web scalers, but Quick and DOH is growing everywhere. So we showed it as a very small slice of the kind of non-big five traffic today, but we expect over the next couple of years that everyone is going to roll out this even more aggressively. I did hear that obviously Microsoft will be deploying it for Office 365, so I think that will affect the enterprise space pretty heavily once that happens. And I think somebody earlier, I've forgotten who, maybe it was Jeff again, but we talked about Mask as the kind of VPN approach for using a Quick transport. Talking to Cisco's own business, the secure access client or VPN client that will be deployed going forward is all Quick-based as well. So I think we're going to see more and more movement towards this across all facets of the network and our networks. Okay, so that's kind of where Quick is at. So that's a bit more data. In terms of how we deal with this, so as a network vendor, customers come to us and talk about the problems that they are seeing. We have a summary here of some of the problems they've seen. So operators typically, traditionally, would like to offer different experiences for real-time video versus video downloads, and we could achieve that with the tools we had. But we know that DPI is not going to work anymore. However, operators are still asking us for some help to be able to do this. Again, mostly on mobile networks because there is contention for radio spectrum, real-time sports, things like that. People are actually streaming. People want to get a good experience. Downloads, not so important. Snap is another use case. I don't really understand what Snapchat is. I'm getting a bit too old, I think. But my kids use Snapchat, and they muck around with the filter thing all the time with, I think, making my hair fall out and getting moustaches and all that stuff. But some operators where Snap is very, very popular are asking us they would like to be able to differentiate between the different Snap applications. But of course, it's using Quick, so they can't do anything for their users. I think someone earlier, again, was talking about legal intercept. So I think there is still this thing from government that we would like to be able to do some sort of legal intercept and see what users are doing. I don't know if this is possible, but people are asking us what can be done and is anything possible at all. So we're looking at that. And then lastly, just to be able to understand what is the traffic profile on your networks to be able to help you do capacity planning, modeling, understand where you should be peering. All these kind of pieces are things that people are asking us for. So we haven't given up. We are working with both our own development and with some ISVs, because there is some information that's not going away, and it is pretty primitive at a packet level. So you will see here on the left-hand side, sorry, my right, source, IP, destination, these things are still there, protocol number is still there. Of course, there's a limit to what they can tell us. We can see the payload size of the traffic. And lastly, this is the new piece that we kind of working on, is looking at what can we see in the time domain. So we can see what is the size of the packet, how often the packet's coming, and trying to work out what we can infer from this data. Of course, it's not as good as what we had, but this is what we have to work with. So on this slide, there's a number of studies that we've been doing, looking at what the different applications look like using this toolkit. So you can see we are actually able to detect different types of media based on this. So if we look over on the left, a traditional TCP stream, we can see we have up front, when the video starts up, a large kind of download of TCP data. In the middle here, we have a startup of a quick session, which obviously be UDP-based. We see a big lumpy download at the start, and then we see an ongoing set of smaller chunks being dropped through the network. And then we see things like UDP-based players using non-quick are kind of just crazy all over the place type stuff. So we can infer from IP address information and looking at the traffic profile, we can actually infer some level of what people are doing and what the application is. Of course, we heard earlier that quick can have many things inside a single connection, but we can differentiate to a level based on this. So what we've been working on is a toolkit where we observe all of the flows in a network. We can profile the different flows over this time domain, as we talked about. And then we can determine something about those flows to see what is video, what is download, what is streaming, etc. So we have, I guess, so far been able to do this. And then observe and categorize traffic. So that's one piece we can do. The second piece we have been able to do, and this is from a kind of an IP network or somewhere in the IP network, is we have been able to infer when the downstream network is congested. So I talked about the radio use case. Cisco doesn't build radios, but from a mobile core or having a system like this close to the mobile core, we can infer whether or not we're seeing traffic behavior where we think that the downstream network is actually congested, because we see the applications start to behave differently when this happens. So we think that's possible. We observe it. We can see if it's congested. That lets us try and achieve something from a policy point of view to help us manage the flows on the network. So the next piece of this, if we can observe both what the traffic is, we can categorize the traffic, and then we can observe if we think we have congestion in the network, we can start to think about a toolkit where we can have a solution where we can do some level of traffic management. Now, this is not our traditional in-network QoS. This is more about managing things at a flow level from a policy point of view and trying to maintain some level of control over what our users are doing to ensure at least some level of fairness for all users, rather than just letting the quick applications blast everything. So you can see here we have a platform with a set of APIs available where we think we can still enact classic things like policing and shaping and provide some level of management. And as I mentioned, we, on our mobile net core at least, we have an application called Qto. What this really does is manages elephant flows. So we're not trying to manage everything. What we're trying to do here is say if the radio gets congested, we can detect congestion. And the big elephant flows, we can do something to, I guess, force them to back off a little bit. They will adjust. The users don't particularly notice, but we get a degree of fairness back on the network, especially in a radio environment where it is contended for every cell. So this is a working thing. Still seems to work to a level today as well. So putting all of this together, our overall toolbox for this is that we have a set of things that we do still see. So the IP address, protocol number, we have the packet size, and the time domain. So we see how often packets are coming, what size they are, and we can do profiling. So we observe the flows. We think we can infer what the flows are, whether things are congested, and then we can do some level of policy. So in terms of use cases that we can build out of this toolkit, so I think the first one is probably obvious. This is the same graphs we've showed earlier, but just being able to visualize and observe what is happening on the network and report on it. So it doesn't give you anything specific you can do from a quality of service or flow management point of view, but the first stage is just to understand what your traffic looks like, where your traffic's going. I think talking to a few people, I think people feel like it's invisible what's happening on the network today, but we can get some level of observation about at least who the main consumers of traffic are, what the applications are, and that might enable you to start some conversations. So beyond observation, the next thing might be that you can differentiate between, say, downloads and streaming again. So again, using this toolkit, we can set a policy per flow type and do some level of management and prioritization of different flow types, especially during congestion. I've got told 5 minutes. I think Lincoln took an extra 15 or so, so I'm not sure, but I'll hurry up. That's okay. Yeah. The other piece is to shape traffic, and I mentioned this as this elephant flow management. So typically, if we have contended resources on the network, most video applications, if they lose a few packets, they will just downgrade the experience for the user, probably to the point where the users don't really actually notice. Certainly, again, my eyes were never very good, and they're failing even more. But I can't particularly tell the difference between many different levels of high definition TV or other things. Doesn't make much difference to me. So a very small downgrade for a bit of a blip in time when there's congestion is something that we do and we think can be valuable. This application, we talked about a lot about radio. Obviously, in Australia, we are lucky enough to have the National Broadband Network, which is a wholesale access network. I have many views on the NBN. I won't share them now because that would be more than 5 minutes. Good and bad. But I think what we're saying here is, in the case, a bit like a radio network, if you have a wholesale access operator, you're not fully in control of the end-to-end experience of the network and your subscribers. But you do have the same kind of idea that you have a CIR coming in from your wholesale operator. When you are using that network, you can treat it a little bit like radio, that you know what your bandwidth's going to be to some extent, and you can use this toolkit to try and provide some level of quality of experience for your subscribers over that contended environment. And of course, Australia is not the only place with wholesale access networks, but this is an example of what we think we can achieve with this toolkit. The last case, being a Cisco employee, I had to talk about WebEx rather than Zoom. We can't really admit full defeat on that one. But the other case that came out through this, again, this is one of the use cases, especially for enterprise we're exploring, is to protect real-time traffic. So things like video conferencing. Obviously, we all get pretty cranky when WebEx or Teams or whatever, the video drops out and it gets pretty hard to understand what people are doing. So we know from a user experience point of view, we would really like to be able to protect real-time traffic over and above other applications. So we think this is another use case that we can tackle with these tools. Okay, so in summary, basically we've all heard that the traffic is encrypted. I think Jeff has said it's all hopeless, and paraphrasing a little bit, maybe he's right. So this is all gonna be here for a long time. We think from a quality of experience point of view, there are things we can still do to manage at flow level rather than at packet level. And like I said, certainly I look forward to turning off some of the old QoS policies and other things that drive me mad personally, probably drive everyone else in this room mad. But we look towards to turn those things off because, yeah, again, we know that going forward they're not really going to achieve any outcome. So thank you.